Anybody get it? What does it say? Yeah. Yeah. This is hypotenuse. Hypotenuse. Okay. Yeah. All right. So what we're going to get into is using the skills that we did for proving congruent triangles or using a congruency statement. Okay. And we got to use the known facts whenever we have a congruency statement. So we're going to start off with this part. It states right here, triangle ABC is congruent to triangle DEF. I am giving you that statement. If you know that, you should be able to give me some facts about the triangles. So what do we know? What parts do we know? What facts can we state about these two triangles? What was congruent to who? I can say angle B is congruent to angle E because corresponding parts in the statement are congruent to each other. B is the middle letter, E is the middle letter. What else? That's one fact. A is congruent to D. That's another fact. F is congruent to C. Yep, that's another fact. So that takes care of the angles. What other fact? AB is congruent to DE. I heard that. And then I heard, yeah, EF is congruent to BC. And AC is congruent to DF. Yes, the sides are congruent. We can make relationships about the angles and then about the sides just from that congruency statement. Well, if I'm looking at a diagram, because you're going to be given figures or triangles, and you're going to be given statements for them, or they're going to be marked. So if I'm going to show that this is true on the triangle, angle B and angle E are congruent, so they should have the same marking. So let's make sure we have it marked correctly. So one arc for angle B and E. For angle A, what am I going to have to do? 2, because if I do 1, I'm stating that it's congruent to B and E, and it's not. Then angle C and F would have 3. So that would show that the corresponding angles are congruent. Then we're going to do the same thing with the sides. AB and DE, that would be one tick mark. BC and DE, or EF, excuse me. I knew that was going to happen. That's showing the other. Okay. 5 ways to prove triangles are congruent. This is just review. Let's see if you remember them. The first one, what's going to go in our parentheses? Yes. Yeah, side, side, side. All right, so side, side, side. We have 3 sides congruent to 3 sides of another triangle. Then they are congruent. SAS or SAS represents side, angle, side. 4 I gave you, angle, angle, side. So what's the third one? Yeah, angle, side, angle. SA, ASA. And then the last, the 5th way, HL. Yeah, hypotenuse, leg. All right, now when can we use HL? Yeah, so we're going to just add that little side note. Use only with right triangles. HL you can only use with right triangles. So we're going to use these previous ways of proving congruent triangles when we get into proofs. When we do proofs, or when we're proving parts, corresponding parts, let me get the highlighter out. The order of the letter is important. Okay? Order is important. And I'm going to highlight some relationships here. So get your highlighter. All right. Number 1, we're going to use our triangle shortcuts, use our markings that are given to us to complete the congruency statement, and order is important. So what do we notice on number 1? Are the 2 triangles congruent? Yes, by, yes, hopefully we see side, angle, side. Tick mark is the side, arc is the angle, another tick mark is the side. We see that same pattern in the other triangle, side, angle, side. Okay, order matters. So if I name it triangle CAU, yeah, XAZ by side, angle, side. Okay, same markings. That's right. You got to follow the markings. Order is important. Oops. All right, now on number 2, we got right triangles. Yeah, we have a look opposite the right angle. There's the hypotenuse that is marked with a tick mark. We have a leg that's marked with another tick mark, HL. So triangle DRE, Dre, is congruent to triangle UBL. I should have made that beats. All right. We're okay on that part. All right, so what we're going to get into is proofs. There's ways we do that, and we've already kind of started on those. First thing I'm going to highlight the order where we start for our proof. What is given is the first line of your proof. Whatever is given to you will be your first line of your proof. If you have a shared side or a shared angle, you're going to use the reflexive property of congruency. If you have a shared side or angle, you're going to use the reflexive property of congruency. If you have any special quadrilaterals, we're going to do properties. What properties does it have that could help? Okay. Sometimes I might give you a rectangle. We're not going to get into too many quadrilaterals because we're going to make sure we know how to prove those first. And then any special angles, that means your vertical and your alternate interior, you are responsible for marking. You will mark special angles. And then other given information. You can have other given like the word perpendicular, midpoint, bisects, altitude. You would add that to your proof. You would use that in your proof. And then the last thing, what you are trying to prove is always the last statement of the proof. What you're trying to prove is the last statement. So our first thing we want to make sure we understand is this reflexive property of congruency. So whenever I see basically a shared side or a shared angle, I'm going to state the reflexive property of congruency. We can say POC to do that. Now, I know the copies are bad because it's up here. It's better. We need to add this base, add the segment WZ so we can see the two triangles. Okay. The minute I see, oops, that's way too big. Oh. Go forward. What happened? The minute I see the shared side, I lost my stuff. There we go. All right, so let's fix this. Our shared side is the W, or is the XY. Okay? When I have a shared side, we are going to state shared side. We're going to basically have a statement and a reason listing that shared side and using the reflexive property. So if I see shared side, you need to do this. You are expected to write that in a proof if you see and identify shared side. Sometimes I'm going to give you parts of the proof. The proofs we're going to do today, I'm going to give you the statements. So anytime we see an expression that has basically the same thing, so if you look right here, see how this is XY, XY, same, looks like a mirror image. Anytime we have the same expression and the congruency sign in between them, this is showing the reflexive property of congruency, POC. So if it's listed out to you showing the same expression, same statement, same segment, same side, then we're going to list the reflexive property of congruency as our justification, as our reason. All right, so a couple things. First thing, common angle is just another way of saying shared angle, okay? Common angle is the same thing as shared angle. Now, I'm going to do two different colors, two different highlighting, so you can see what happens with overlapping. All right, so we're looking at triangle ACD. I'm just going to trace that. ACD. That is that triangle there. Okay, highlight it so you can see what happens. We have ACD, and then we're looking at triangle ECB. ECB. That triangle there. Do you see that they're overlapping? Okay, so what we have is basically this is an example of overlapping whenever you have overlapping triangles, they share a common angle. Where is that common angle? C. Yes, C is in both of them. So what I want you to be able to see is if I separate these, sorry, I just had you. There we go, boom. All right, so we have them separated, right? We know that they both share C. It's overlapping for them. Then I would say that angle C is congruent to angle C using the reflexive property of congruency. Reflexive property of congruency. Being able to recognize shared sides, overlapping triangles is going to help us when we have to prove them. So what we're going to do now is we're going to prove the parts. Here we go. Parts that are congruent. So on our next page, there's this acronym you need to use and need to recognize and know what it means. CPCTC. C is for corresponding. The corresponding parts of congruent triangles are congruent. The corresponding parts of congruent triangles are congruent. The very first thing I asked you was to give me the 6 facts about the congruency statement, about those congruent triangles, okay? So, in order to use CPCTC, you first have to prove the triangles are congruent. That is the first thing that has to come. If you can do the first, which is prove the triangles are congruent, then you can use CPCTC. I'm going to show you how we're going to do that. What is, I guess, the CPCTC in reference to? So, like, let's say I have a triangle, ABC, and I have a triangle, XYZ. If I tell you that the triangles are congruent, right? I'm telling you they're both equal. Then, what could I say about AB? That side, that part is congruent to XY. So, That's what I'm saying. We first have to know that the triangles are congruent. Then I can tell that the parts that correspond to each other would be congruent as well. Okay, that's the conclusion we could make. So there are some steps we're going to follow to make sure we can do that. First thing, if you see prove, that word right there, prove. See, we have prove that angle E is congruent to angle G. This would be our last statement in our proof. So this is our last statement. Well, whatever I tell you to prove, that's going to be the last thing you would have to write in a proof. Right here, oops. F is the midpoint of EG. Angle D is congruent to angle H. This is what we call given information. So this is our first statement. Whatever is given to you will be your first statement in your proof. Well, that explains how we're going to start this. Step 1 will be to mark the given information. Okay? Mark your triangle according to the given information. Our given information was F is the midpoint of EG. How would I show that? Tick marks between EF and FG to show F is the midpoint of that segment EG. What else was given was angle D is congruent to angle H. So I need to add the arc for D and the arc for H. Mark your given first. Now, second is you're going to mark known facts. Usually known facts are in this order. Vertical angles, then you check shared sides or shared angles, then alternate interior angles only if the lines are parallel. Only if you're given parallel lines. So, any known facts we can mark on this diagram. The vertical. So we're going to do double arcs. There are my vertical. The third step, after you get everything marked, you're going to determine which congruency theorem you could use. Are these triangles congruent? Which theorem? Yeah, because we have an angle, and a side. That included in that angle. Angle, side. All right, so what we're going to state, in order to do this, what we're trying to prove, remember, what we're trying to prove is angle E is congruent to angle G. That's our last statement. Before I can get to the last statement, I must prove that the triangles are congruent. So we're going to say right here, oops, triangle. Let's name the triangle. Where do you want to start? DFE. Okay, so DFE. If I start with D, triangle DFE is congruent to triangle HFG, right? And we would say by angle, side. So you must state that first. You must state that the triangles are congruent before you can make your last statement. Our last statement is angle E is congruent to angle G. If you can state this, since we did this first, now I can do this. And once I have stated the triangles are congruent, all I have to do is say the parts are congruent using CPCTC. So angle E is congruent to angle G by CPCTC. Should have put the word by. So on the last step 4, whenever you have that the triangles are congruent, you're going to restate the statement using your CPCTC. All right, so we're going to get into some practice. So flip over your paper. We have an example, and then we're getting into the proofs. Yes? Yeah. Huh? What? No, we're going to finish this in class. All right, first thing, number 2, example 2. Mark the known or given information. Sorry, mark the given information. E is congruent to angle W. Angle E is congruent to angle W. M is the midpoint of WE. Tig mark to show midpoint, 2 congruent segments. And then we mark our known fact. What's the fact we know in the diagram? Vertical. So they want to know, is MO congruent to MN, and why? MO is the side. Would that side be congruent to the other side, MN? How do we prove that? You're right, they are congruent. Why? What was that? ASA. We have angle, side, angle. So what does that tell me about the triangles? They're congruent. So that's what we have to state first. We first have to state the triangles are congruent. So I can say triangle WMO is congruent to triangle EMN by angle, side angle. Now that we know that they're congruent, we can say yes, MO is congruent to MN by CPCTC. You must state the triangles are congruent before you can say anything about the parts. Make sure we have that. All right, so for our first proof, I've given the statements. We're going to make sure we mark it, and we can give the reasons. First proof. Number 1, statement. Angle 1 is angle 2. What's our reason for that? Angle 1 is... Oh, jumping. What's always our first line? Given. Given is always the first statement. The first line. It's right here. It says it right here. Given. Angle 1 is congruent to angle 2. So I'm going to go ahead and mark that. Angle 1, angle 2 are congruent. Same marking. Then their second statement says angle 3 is congruent to angle 4. It is also given. So we can have 2 lines of given. We can have a given in the middle of the proof. If it's, as long as it's, I see it and I read it from our given statement. So yeah, we have 2 arcs. 2 arcs. Statement 3 says segment DB is congruent to segment DB. What is that? Yeah, that is a reflexive. Property of congruency. They just marked or stated the share side. For statement 4, now they're saying that the triangle ABD is congruent to triangle CDB. How do they know that? By what reason? Yep, angle, side, angle. And then statement 5, the last statement, which has to be what we're trying to prove. Does that match? Yes, it does. How do I prove that the segment BD is congruent to CD? Very good. CPCTC. Because we proved that the triangles are congruent, now I can state something about their parts being congruent as well. Okay? All right, so the last proof, this one is pretty complex, okay? We're just doing it as an example together so you can understand it. So I do need you to do it with me, okay? Because I know I'm not going to give you one this complicated, but I want you to understand how you can have more than one triangle congruency in a diagram. The first thing I want you to do you understand what they're trying to show you with these 2 little kind of bubbles, dot bubbles? Understand that this right here is from the middle, the interior, and they just redrew it, okay? Right here, this was redrawn as well. First thing I want you to do for me is, oh, I'm missing my C. Okay, first thing I want you to do is over here to the right, let's just draw the triangle that we are starting with, which is the whole triangle, which is CAE. Okay? What I want you to understand is, first, this ABD triangle right there, I got from tracing in the interior of that triangle, ABD. And then our ADE from this triangle here. Did we see what happened there, right? I'm hoping you see that basically they pretty much overlapped. They just separated them. Oops. Are we okay on that part? All right, so what I'm going to do is I'm going to move this over here just so you know. Oops, it goes right there. That these went with this picture here. Okay. I'm gonna erase that. All right, so the first thing, statement 1, CA is congruent to CE. Where do we get that from? Given. Good job. Given. All right, so I'm going to show that, but I'm going to show it on our drawing that we have over here to the side. CA is congruent, because I don't want it to get confused with what we have in the interior. All right, BA is congruent to DE. That is also given. Now, where on the diagrams do I see a BA and a DE? Yeah, on the smaller triangles right here. So I'm going to do a tick mark, 2 tick marks, 2 tick marks. Over here too, BA, DE. Okay, they're on the smaller triangles. Now, the second statement, they drew a conclusion based on our original statement, our original triangle. You see our triangle here, CAE? See what we marked? Is there anything you know about this triangle? What conclusion? It's isosceles, okay? So we can, if I can see there's two congruent sides, I know it's isosceles. So I can be able to draw a conclusion about another fact to this triangle. What else should you know after knowing that the sides are congruent for an isosceles triangle? The angles are congruent. So if I have 2 tick marks, then those angles that are opposite those tick marks are congruent. So if I have an isosceles triangle, I have 2 congruent sides, and I also have 2 congruent angles. So in this first statement right here, angle CAE, that's this angle that we had in our isosceles triangle. Angle CEA are congruent. They got that information. They drew that conclusion from the definition of isosceles triangle, or the isosceles triangle theorem. The theorem states that if I have congruent angles, then I know the corresponding sides are congruent, and vice versa. Now, look at statement 4. AE is congruent to, that is reflexive. Property of congruency. Now, I need to mark that. Where is my AE? Right here, bottom 2. So I'm going to put 3 tick marks. Because it overlapped right here. So this, basically, they're trying to show you that those sides overlapped. Those were overlapping sides. All right, now, before we go to the next statement, remember how we marked this angle A and this angle E? Do y'all see that? Does that angle exist in another triangle? Because don't I see that this angle A here is the same angle in the A here? All right, so I'm going to mark that angle. Angle A is the same angle A here, so they'll have an arc. Angle E is the same angle E there. So, how do I know it's bisected? Oh, because if you're talking about here, I don't know it's bisected. I do know that this and those together make that angle, but I don't necessarily know that they're congruent parts. So I could do addition, but not necessarily dividing. Okay? All right, now, you see our triangle here? That's the statement that goes with statement 5. Or that's the triangle that they're using for statement 5. It says triangle BAE is congruent to triangle DEA. Do I have evidence to prove that right here? By what? Huh? Yeah, side angle side. This one is side angle side. Well, in statement 6, it says, well, if I have the triangles are congruent, then it says angle ABE, so that is, and I'm going to put that in green. AB is this angle here, and angle EDA, that's that angle there, are congruent. How do we justify that? We just added another part. CPCTC. Why? CPCTC. Maybe if I do this. All right. CPCTC. All right. Next statement. Statement 7. What are they saying in this statement 7? Where are they getting that from? Yeah, what about in that small picture? Vertical angles. So 7, statement 7 is vertical. So go ahead and mark the vertical angles in the small picture. I can't mark it up here, guys, so just kind of do it yourself. I can't even move this thing up.